Okay, let's unpack this. Have you ever found yourself in that weird space between sleep and waking? You know, where a dream feels so incredibly real, you can almost taste it. But then, just for a second, you kind of realize it's all in your head. Or maybe you've heard stories, right? About meditators achieving these states of just profound calm or like laser sharp focus that seems, well, almost superhuman. For centuries, maybe millennia, these kinds of experiences, the vivid ones, the sublime ones, they felt like glimpses into something mystical, maybe beyond our grasp, possibly even beyond science itself. But what if they're not? What if these aren't just random brain glitches or, spiritual revelations? What if they're actually sophisticated hacks to your brain's basic operating system, just waiting to be understood, maybe even controlled?
That's exactly the shift we're seeing now. It's really quite compelling how this whole scientific quest for understanding consciousness, how it's moved from purely philosophical speculation, thinkers pondering the mind-body problem for ages, to really rigorous empirical neurobiological research. We're actually looking inside the brain.
Right.
We're moving from the realm of, what if we could explain this, to, okay, what is actually happening neuronally? We're starting to unravel the measurable, the objective signs of our internal subjective world. And that's a monumental leap, really. It changes how we approach one of life's biggest mysteries.
And that's precisely what we're setting out to do today. We're diving deep into hacking the mind, the science of dreams, meditation, and altered states. We're going to pull back the curtain on this really comprehensive report. And it argues that altered states of consciousness, ASCs, they call them MOS, and this covers a huge spectrum, right? Everything from your most vivid dreams to those deep meditative trances, psychedelic trips, the weird and insightful ones, AMAs, and even those deeply moving stories you hear about near-death experiences. The report argues these are not just mystical or, unquantifiable things. Instead, they're actually measurable neural processes driven by very specific identifiable changes in your brain.
Exactly. Our mission here in this deep dive is to synthesize this current research, to try and make sense of it. We want to show how these seemingly really different states, they have varied triggers, different feelings at school, but often they seem to share a common underlying mechanism. And that mechanism is the modulation of key brain networks. Chief among these, and we'll talk a lot about this, is the default mode network, or DMN. It's just so deeply involved in our everyday sense of self, our internal chatter, our place in the world.
Right, that inner monologue.
That's the one.
So this report in our deep dive today, it puts forward a really bold idea, maybe even audacious, that we are rapidly entering, maybe we're already in an era of consciousness hacking. Think of it like directly interfacing with your brain software. So traditional practices like meditation are often seen as spiritual, right? Through this lens, they look like gradual, long-term hacks on these brain networks. You're patiently retraining, rewiring them over time.
Slow and steady.
Exactly. But then on the other hand, you have newer approaches like carefully administered psychedelics or these really cutting edge neurotechnologies. And they seem to offer faster, much more direct interventions. They kind of bypass years of practice to induce similar neural changes. And this isn't just abstract theory for the lab coats. It promises potentially groundbreaking therapeutic benefits for mental health, amazing possibilities for cognitive enhancements. But, and this is a huge but, it also throws up these profound, really urgent ethical questions about human identity, our autonomy. What does it even mean to be conscious and human in the 21st century?
It opens up a whole Pandora's box, doesn't it?
It really does. And this isn't just a chat for neuroscientists or philosophers, although they're definitely deep in it. This deep dive is for you. It's about understanding your mind, your experiences, and understanding the incredible potential, but also the significant challenges that lie ahead, especially as we, as a society, as individuals, learn to directly influence our own consciousness. So get ready to maybe shift your perspective a bit. You might just have a few serious aha moments about your own inner world today. Okay, so to really get this idea of hacking the mind, we probably need to start at the beginning. What exactly do we mean by consciousness? It's a word we use all the time, but scientifically it's been, well, slippery, hasn't it?
It's absolutely the crucial starting point. Historically, thinkers use terms like waking state or sentience, subjective experience, often pretty much interchangeably with consciousness, but without a really precise empirical definition. You mentioned John Locke back in 1690, his definition, the perception of what passes in a man's own mind, was foundational. Groundbreaking for its time, definitely, but still largely philosophical, speculative.
Right, not something you could easily measure.
Exactly. But today, neurobiology is grounding this whole debate in empirical research. Measurable stuff. We're actively trying to bridge that classic mind-body gap. moving beyond just asking what consciousness is, philosophically, to asking how it actually arises from the physical stuff of the brain. This shift is huge. It means we're not just describing mental feelings, we're identifying precise, quantifiable links between subjective states, your inner experience, and objective brain states, the electricity, the chemistry.
So it's connecting the feeling to the firing.
In a nutshell, yes. And understanding this shift helps you, the listener, appreciate just how massive this is, how something that was once purely personal, private, is now being tackled scientifically, with real rigor, new tools.
Okay, so if we're moving from philosophy to the lab, how do scientists measure something so inherently subjective, so private? How do they actually find consciousness in that, incredibly complex network of the brain? It sounds impossible, like weighing a soul.
Huh. That's a great way to put it. And it brings us right to a central concept here, the hunt for the neural correlates of consciousness. NCCs. Now, NCCs are defined as the minimal set of neuronal events and mechanisms that are sufficient for a specific conscious mental state to pop up.
The minimum needed.
Exactly. Scientists are looking for that specific neural signature that always comes along with a particular subjective feeling, like seeing red or feeling happy. Now, it's really important to clarify, finding NCCs doesn't solve the hard problem of consciousness.
Right, the why it feels like something.
Okay, and precisely.
Right.
A hard problem is that deeper puzzle of why any neural process should be accompanied by subjective experience at all, or why this neural pattern feels like redness and not blueness or nothing. NCCs tell us what brain activity corresponds to consciousness, but not the fundamental why. But even without solving that ultimate mystery, identifying NCCs is absolutely essential. It's a foundational step. It's how we build towards a truly causal theory, one that could eventually explain how the brain generates subjective experience.
So how do they find these NCCs? What are the tools?
Well, researchers use an impressive toolkit, sophisticated techniques, really. Things like functional magnetic resonance imaging, fMRI, doesn't measure neurons directly, but changes in blood flow linked to activity, shows where the action is. Then there's electroencephalography, EEG. That records the brain's electrical buzz directly from the scalp. Great for timing, it sees changes very quickly. And also positron emission tomography, PET, uses a radioactive tracer to see metabolic processes like which areas are using more energy.
Wow, okay. So different ways of looking at brain activity.
Exactly. And these tools allow for real-time recording of these dynamic changes in brain activity. And this is critical. They correlate these objective readings with a person's real-time personal reports of what they're experiencing subjectively. This creates that tangible bridge, right, between the objective measurements and your private internal world. So when you wonder how science can possibly probe something so private, these tools are the answer. They make the intangible measurable.
Okay, so these tools help us find the links, the correlations. But beyond just finding those connections, are there bigger theories? Frameworks trying to explain how the brain actually generates this whole subjective show?
Absolutely. And this is where things get really interesting, theoretically speaking. Our understanding now is shaped by several theories, sometimes competing, sometimes overlapping. But they often converge on a key idea. Consciousness seems to be about integrating information, about widespread communication in the brain.
Information integration. Okay.
Let's touch on a couple of the big ones. First, there's the global workspace theory, or GWT, championed by Bernard Bars. The core idea is pretty intuitive, actually. Consciousness arises when information gets broadcast globally across different specialized brain regions.
Broadcasted, like on a network.
Sort of. The idea is most brain activity is unconscious, happening in parallel in specialized modules. Think of them like little departments doing their own thing. Consciousness emerges when important info from these modules gets pushed into a global workspace, making it available to lots of other processes, memory, attention, planning. The metaphor often used is the theater of consciousness.
Ah, yes, I've heard of that.
Right. Most work happens backstage, unconsciously. When something becomes conscious, it's like it steps into the spotlight on stage, visible to the whole audience of other processes. This broadcasting makes the information widely accessible, integrated. The neural hardware for this, thought to be a widespread network, especially involving the prefrontal cortex, or CEO, and the anterior temporal lobe.
And the strengths of this theory?
Well, it explains a lot of data quite well about waking states, attention, memory, even what happens with brain damage. But it does get hit with the Cartesian theater criticism, meaning if there's a stage and a spotlight, who's watching the show? It risks implying a little person inside the head, an internal observer, which leads to an infinite regress problem. Who's watching the observers observe it?
Right, okay. Turtles all the way down.
Something like that.
Yeah.
Then a very different approach is integrated information theory, or IIT, developed by Giulio Tononi. This one is much more mathematical, more abstract. Its core idea is that consciousness is integrated information, quantified by a mathematical measure called A, or phi. Phi. A system with highness, meaning it's both highly integrated, its parts work together, and highly differentiated, it can be in many different states, possesses consciousness. So the human brain, with incredibly high A, has rich conscious experience. A simple camera, low A, has little or none. The mechanism proposed involves systems with that high integration and differentiation, like the thalamocortical system, the network linking the thalamus and the cortex.
So it's about the complexity and interconnectedness.
In essence, yes. IIT starts from phenomenal axioms. Things Tononi argues are undeniable properties of conscious experience itself. Like it exists, it's structured, it's specific, its strength is this formal mathematical framework. It's revolutionary in that sense. But like GWT, it doesn't quite solve the hard problem. And its claims about what fundamentally exists, this ontology, can be pretty controversial.
Are there others? Briefly?
Sure. There are also higher-order theories. They focus more on metacognition. The basic idea is that consciousness arises when you have a thought about your own experience, a mental state representing another mental state.
Like thinking about feeling sad makes you consciously aware of the sadness.
Roughly, yes. A kind of self-monitoring. So if we tie this all back to the main theme, what's really compelling is that GWT and IIT, despite their different approaches, they both point towards information integration and widespread communication being crucial for consciousness. This suggests that consciousness hacking, this idea of intentionally altering our states, fundamentally about manipulating that flow, manipulating the integration of information in the brain. So any intervention meditation, a drug, a technology that tweaks this process, by definition, that's a form of hacking.
That makes sense. These theories give you, the listener, a framework, a way to understand how your brain builds your reality. And it makes the idea of hacking it feel more concrete, less like magic.
Exactly. It's about influencing the very architecture of your subjective experience.
Okay, so from these big theories, let's pivot. Let's talk about something incredibly personal, universal, and often, well, just plain weird. Dreams. We all do it pretty much every night. But what's actually going on in our brains when we drift off into those nightly stories? Is it just random static?
It's a fantastic question. And what's really fascinating is that dreaming isn't just static at all. It's a truly unique altered state. Your mature brain is highly activated, sometimes even more active than when you're awake. But crucially, it's disconnected from outside sensory input. And usually it lacks self-reflection. We don't typically realize we're dreaming.
All right, you just accept the talking pineapple as normal.
Exactly. That lack of metacognitive awareness is key. It makes dreaming a spontaneous altered state. And this whole nightly journey is managed by the sleep-wake cycle, which itself is run by this complex dance between specific cell groups and neurotransmitters in the brainstem. You have aminergic cells releasing serotonin, norepinephrine, they tend to suppress REM sleep, and then cholinergic cells releasing acetylcholine, they promote REM sleep and the vividness of dreams.
So it's a chemical seesaw controlling our sleep stages.
A very sophisticated one, yes. Early research also mapped out brain networks involved, like a posterior network, including the temporal-parietal junction, TPJ. Damage there can affect dream details like color or movement, and an anterior network, including the ventromedial prefrontal cortex. Damage there can actually cause a complete loss of dreaming anonyria, which shows dreams aren't just fluff, they're tied to specific brain structures.
And what about the purpose of dreams? Has our thinking changed on that?
Oh, significantly. We've moved way beyond just Freudian interpretations. Initially, back in the 70s, there was the activation synthesis hypothesis from Hobson and McCarley. Their view was basically that dreams are just the brain trying to make sense of random electrical noise firing off during REM sleep.
Like the brain telling itself a story based on static.
Pretty much. In that view, dreams don't have deep meaning. They're just your cortex trying to create a narrative out of random signals from the brainstem. But modern research offers much more functional theories. One big one is memory consolidation. Dreams might be where the brain replays, sorts, strengthens, and integrates the day's memories and information, like filing things away properly.
Cleaning up the desktop overnight.
A good analogy, but here's a really thought-provoking newer idea. The overfitted brain hypothesis. It draws an analogy from machine learning, AI.
Overfitting, like when an AI gets too good at specific data but can't handle anything new.
Exactly. It performs brilliantly on its training data, but fails on novel stuff. This hypothesis suggests dreams deliberately introduce noise, discord, those bizarre illogical elements,
Yes.
to stop the brain from becoming overfit to the repetitive routines of daily life. Essentially, dreams keep your brain flexible, adaptable, creative. They shake things up.
Wow. So the weirdness is a feature, not a bug.
That's the idea. It explains why dreams often contain those fabulous and unusual events. They're not just random, they might be strategically random, designed to keep us cognitively flexible.
That's a huge shift. So my bizarre dream last night, flying a banana over a city of talking cats, that might actually be my brain's clever way of keeping itself flexible, preventing mental ruts.
According to this hypothesis, yes. It reframes dreams entirely. Not as random noise or psychological garbage, but as a vital, purposeful mechanism for learning, for improvement.
It changes everything about how you think about sleep, doesn't it?
It really does.
Yeah.
And it opens up possibilities, Could we influence dreams for cognitive benefits?
Fascinating. And speaking of influencing your internal state, which is core to this hacking idea, what about lucid dreaming? Being aware you're dreaming while dreaming, that feels like a direct peek behind the curtain. This gets really wild.
It absolutely does. Lucid dreaming is remarkable. A unique hybrid state, really. It beautifully blends features of waking consciousness, that self-awareness, with the dreaming state. It's a perfect, natural example of a consciousness hack. It shows, unequivocally, that metacognitive awareness and self-awareness can be switched on even in a state normally defined by its absence.
So what's happening in the brain during a lucid dream? Is it different?
Very different and very telling. Lucid dreaming is linked to a marked increase in activity in specific prefrontal cortex areas, particularly the right dorsolateral prefrontal cortex and the frontopolar areas. Now, this is hugely significant because these regions are crucial for self-awareness, critical thinking, decision-making, our executive functions, and normally during typical REM sleep, these areas are less active, sometimes significantly so.
So they wake up within the dream.
That's a great way to put it. They come back online, allowing for that higher order awareness. And what's even more compelling is that scientists can objectively verify this subjective state. In the lab, lucid dreamers can agree beforehand on signal-specific sequences of eye movements. And they can perform these signals from within the dream to communicate that they are, in fact, lucid.
No way. They can signal out.
Yes, it's incredible. It provides a solid, observable neural correlate of consciousness for lucidity. A direct link between that specific mental state and measurable neural activity, verified by behavior. It just powerfully shows you, the listener, the amazing capacity of your own brain. Gain self-awareness, even exert control within otherwise unconscious states. It really blurs the lines between waking and sleeping.
That's mind-bending. Okay, so from accidental awareness in dreams to deliberate practice, meditation, it's ancient, it's everywhere. Scientifically, what's the hack here? How does just sitting quietly change your brain so profoundly?
Well, meditation isn't just sitting quietly, right? It's active mental training. And viewed through this lens, it's a deliberate long-term hack that trains the brain to manage its own internal state. And the key is, it leads to lasting structural changes, what we call trait effects, changes that stick around even when you're not meditating.
Actual physical changes in the brain.
Yes. Numerous studies show long-term meditators have increased gray matter volume, particularly in places like the prefrontal cortex, again, crucial for attention, emotional regulation, and the insula, important for body awareness. And there's even fascinating research suggesting meditators' brains might age slower structurally, less gray matter loss over time.
Younger brains. How?
The thinking is it might be linked to stimulating dendrite branching, synaptogenesis, making new connections, and also potentially reducing stress-related damage in areas like the hippocampus, which is vital for memory.
Wow. And what about specific networks? You mentioned the DMN earlier.
Exactly. The default mode network is a primary target of meditation. Remember, the DMN is your brain's idle mode network, active during mind wandering, thinking about yourself, ruminating.
The internal chatterbox.
That's it. Meditative practices essentially train you to recognize when that chatterbox gets loud, when the DMN is highly active, and then intentionally, skillfully redirect your attention away from it, usually to the breath or bodily sensations. You engage your attentional and executive control networks to do this. And doing this over and over, noticing, redirecting, that repetition strengthens the connections between those attention networks and the DMN.
So it's neuroplasticity in action, rewiring through practice.
Precisely. It's a classic example. You're reshaping the functional landscape of your brain. And over time, this leads to greater control over attention, better emotional regulation, less getting lost in thought. We even see measurable outcomes like reduced activity in the amygdala, the fear center, leading to less subjective fear and anxiety. So, through consistent practice, you can literally reshape your brain's hardware, gain more control over your focus, your emotions. It's profound.
Incredible control. Okay, and then there's flow, that feeling of being completely in the zone, effortless action, time disappears. Is that another kind of brain hack?
That's a really insightful connection to make, because while meditation is deliberate training, flow often feels spontaneous, right? Yet neurobiologically, they share striking similarities, different paths to a similar state. Flow is defined as that energized focus. Full immersion, action, and awareness just merge. And it tends to happen when your skill level perfectly matches the challenge of the task, the sweet spot.
Not too easy, not too hard.
Exactly. And the brain in flow has a unique signature. Like meditation, flow involves a significant reduction in prefrontal cortex activity and, crucially, DMN activity. That DMN quieting is key. It leads to that loss of self-awareness, the silencing of the inner critic. You stop thinking about yourself doing the thing, you just do it.
So less self-consciousness.
Precisely. And at the same time, flow involves a release of neurochemicals like dopamine pleasure, motivation, and norepinephrine focus, alertness. Makes it feel good and effortless. Brain scans show enhanced cognitive control, reward coding. The brain is working efficiently and loving it. It adopts this flexible and modular neural network topology. Basically, it organizes itself optimally for the task, saving energy.
So comparing meditation and flow.
The comparison is powerful. It shows two different hacking strategies leading to a similar core outcome. Modulating the DMN, enhancing focus. Meditation is the deliberate training, building the capacity to quiet the DMN. Flow is often the spontaneous result of that mastery, when the trained brain engages optimally with a challenge. The neuroplasticity for meditation helps enable flow.
So understanding flow helps you create the conditions for it.
Potentially, yes. By understanding the balance of skill and challenge, the importance of minimizing distractions that activate the DMN, you can help set the stage for experiencing that peak performance state more often. Whether through practice or engaging activities, it's about optimizing your brain's potential.
Okay, we've covered these natural internal hacks, dreaming, meditation, flow. Now let's shift to external interventions, using substances. Psychedelics. They have such a long, complex, definitely controversial history.
Yeah.
How do they hack the mind chemically? What's the mechanism? This is where things get really profound scientifically.
Right. If we connect this back, classical psychedelics, things like psilocybin from mushrooms or LSD, they offer a much, much faster, more direct, and often incredibly intense intervention compared to, say, meditation, their primary action. They are potent agonists for serotonin 5-HT2A receptors in the brain.
Agonists, meaning they activate them.
Exactly. They bind to and stimulate these specific serotonin receptors, mimicking or amplifying serotonin's effects. And serotonin is just crucial for so much mood, perception, cognition. This particular action at the 5-HT2A receptor is thought to be directly responsible for those profound hallucinogenic effects, the altered perceptions, the changed thought patterns.
And what about something like MDMA? Is that different?
Very different mechanism, though equally potent. MDMA isn't primarily a receptor agonist. It's a powerful serotonin and dopamine releaser and reuptake inhibitor. So it causes a flood of these neurotransmitters into the synapse and stops them from being cleared away quickly. Levels skyrocket. And that leads to its characteristic effects, the enhanced empathy, prosocial feelings, emotional openness, less classical hallucinations, more emotional alteration.
Okay, different chemical tools. Now, this idea of ego dissolution often comes up with psychedelics. Losing your sense of self. How does that abstract feeling connect to the brain networks we've been talking about, like the DMN?
That's a critical link, because this subjective experience has very concrete roots. What's fascinating and a really consistent finding is that classical psychedelics dramatically scramble and desynchronize the default mode network, the DMN. Remember, the DMN is the seat of our self-referential thought, our internal narrative, our sense of being a separate, stable self, our ego's home base, if you will.
Right.
So when psychedelics temporarily disrupt and desynchronize this network, that directly leads to the experience of ego dissolution, that feeling of boundaries blurring, oneness, the self dissolving into something larger. It's a hallmark of the experience because the network supporting the self is offline or scrambled.
So it's literally taking the self network offline.
Or at least radically altering its coherent function. And this doesn't just cause a loss of self, it also seems to make the brain much more flexible. It allows for breaking out of rigid, ingrained patterns of thought and behavior, the kind of patterns that characterize depression or anxiety.
And MDMA, you said it's different.
Yes, MDMA's effect is more targeted towards emotion and fear. Not typically full ego dissolution. It significantly reduces activity in the amygdala, the fear center, and simultaneously it promotes fear extinction learning, helping to unlearn fear responses. It does this partly by boosting activity and connection between the hippocampus memory and the prefrontal cortex emotional regulation. This specific profile allows people, especially in therapy, to revisit trauma without that overwhelming fear response, which is huge for PTSD treatment.
So how are these used therapeutically? Are they just magic bullets?
No, definitely not magic bullets. It's crucial to understand they aren't seen as standalone cures. They're increasingly viewed as powerful catalysts for psychotherapy. Accelerants, almost. We're seeing very promising trial results, psilocybin for depression, MDMA for PTSD, often in people who haven't responded to anything else. But the real therapeutic power seems to come from the combination of the drug-induced state and the psychological work done with the therapist.
So the drug opens a door and therapy walks you through it.
That's a perfect way to put it. The drug creates this temporary window of enhanced neuroplasticity. The brain becomes more malleable, more open to new learning, new perspectives, new emotional connections. This heightened plasticity creates the ideal biological conditions for the hard work of therapy, breaking old patterns, building new ones.
And comparing this back to meditation.
The comparison is really illuminating. It highlights these common principles. Meditation is the slow burn, right? Gradual, effortful training over years to gently weaken the DMN's grip, strengthen attention networks. Psychedelics achieve a remarkably similar neurophysiological state. DMN desynchronization, increased flexibility, plasticity, but in minutes or hours. Through direct chemical action, it shows how different hacks, natural effortful versus chemical rapid, can converge on similar brain mechanisms to alter consciousness.
It offers you, the listener, a glimpse into how substances can fast-track states that might otherwise take years of practice. Huge potential for healing, maybe.
Huge potential, yes,
Yeah.
and for understanding the mind's plasticity, but also significant risks and unknowns still.
Definitely. Okay, so we've done deliberate hacks, natural and chemical. What about the ultimate uncontrolled hack, the near-death experience, NDE? These profound, often life-altering events people report from the brink of death. What's science saying about these?
That's a profound area, absolutely. And it really probes the brain under extreme stress. NDEs are these collections of intense subjective experiences reported by people who face death, cardiac arrest, trauma, coma. And common themes emerge across cultures, right? Out-of-body experiences, feelings of peace, seeing lights, life reviews.
Things that sound very spiritual or otherworldly.
They often do. But neurobiologically, the hypothesis is gaining ground that these are results of disturbed bodily multisensory integration or extreme ischemic stress, lack of oxygen, lack of blood flow to the brain. Essentially, they're increasingly viewed as complex hallucination-like phenomena generated by the brain's own stress response during a major physiological crisis.
Okay, so the brain generating unusual experiences under duress. What about out-of-body experiences specifically? That seems particularly strange.
The OBE is one of the most studied parts of NDs, feeling like you're floating outside your body looking down. And research has pretty consistently linked this specific experience to dysfunction in a particular brain region, the temporoparietal junction, the TPJ.
We mentioned the TPJ with dreams earlier.
We did. It's a critical hub, a multimodal association area. Its job is to integrate sensory information, vision, touch, body position sense, proprioception, to create our stable sense of self-location, where I am. When the TPJ's function is disrupted by epilepsy, electrical stimulation in experiments, or the extreme stress of an NDE, it can lead to that bizarre perception of seeing your own body from the outside. It powerfully shows how our sense of being in our body is actively constructed by the brain.
So NDEs, especially OBEs, are like the brain's self-representation system glitching.
That's one way to frame it. And this makes NDEs incredibly valuable for consciousness research. They're like a natural experiment. We can't ethically induce them, obviously, but they give us this unique, if terrifying, window into brain function at its absolute limit, near collapse. The consistency of reports, like OBEs, across people, and linking them to specific regions like the TPJ, it provides spontaneous confirmation, really, that consciousness, our sense of self, is a biological product of the brain.
It's like reverse engineering consciousness by watching it break down.
Exactly. If meditation and psychedelics are intentional hacks on the brain, NDEs are uncontrolled pathological hacks that happen to the brain. By observing the system falter, we learn how it works when it's whole. These extreme experiences offer you a powerful, maybe unsettling reminder how deeply your sense of self, your reality, even where you feel located, is tied to the delicate functioning of your brain. It shows the fragility and the power of consciousness.
Okay, we've journeyed through natural hacks, chemical hacks, even crisis hacks like NDEs. If we can observe consciousness, induce altered states, chemically tweak them, what's the next logical step? The ultimate frontier. It really sounds like we're heading towards direct technological intervention, literally plugging into the brain. Things like brain-computer interfaces, BCIs.
You're absolutely right. BCIs represent arguably the most direct, perhaps the most potent form of consciousness hacking we've discussed so far. They establish a direct communication pathway, a real-time data bridge between the brain's electrical activity and external machines or computers. And they exist on a spectrum, right? From non-invasive EEG caps picking up signals from the scalp, to highly invasive systems needing surgery to implant electrodes right into the brain tissue itself.
And the initial purpose was mostly therapeutic.
Primarily, yes. Think about restoring communication for people with locked-in syndrome, fully conscious but unable to move or speak. Life-changing. Or allowing paralyzed individuals to control robotic arms, wheelchairs, computer cursors, just with their thoughts. Incredible feats of engineering and neuroscience. But the potential is rapidly expanding beyond just rehabilitation. Researchers are actively exploring BCIs to, as they put it, unlock human neurocognitive potential, even in healthy people.
Enhancement, not just repair.
Exactly. Things like memory restoration for age-related decline, or even general cognitive enhancement, boosting focus, learning speed, working memory for anyone.
How do BCIs differ fundamentally from, say, meditation or drugs?
The key difference is the direct, bidirectional link. Unlike indirect methods like meditation influencing brain states slowly, or drugs working through broad chemical pathways, BCIs can both read brain activity and inside-out hack, decoding intent or thoughts from neural signals. And they can also write to the brain, stimulate neural activity to induce changes, an outside-in hack, directly influencing function. This two-way street represents the most advanced hack we've talked about. It can bypass, augment, or even override natural brain processes with incredible precision.
It's staggering. Imagine your thoughts controlling a drone or technology directly boosting your memory. It's not sci-fi anymore.
It's rapidly becoming reality, a reality that will profoundly shape your future and humanity's future.
Okay, BCIs are the high-end, maybe invasive end. Are there other neurotechnologies? Perhaps less invasive, more accessible ways to directly hack the brain?
Yes, absolutely. There are other approaches showing real promise, often less invasively. Two great examples are neurofeedback and transcranial direct current stimulation, or TDCS. Neurofeedback is really interesting. It's non-invasive and it's learning-based. An individual gets real-time feedback on their own brain activity, maybe shown as a game or a graph on a screen, like a mirror for your brainwaves.
So you see your brain activity and learn to change it.
Exactly. Through operant conditioning, getting rewards when your brain hits a desired state, you can learn to voluntarily reproduce those states, like increasing alpha waves for relaxation or specific beta patterns for focus. The goal is both therapy for things like ADHD or anxiety, and also sophisticated self-regulation, training your neural networks.
Learning to tune your own brain.
Precisely. And then there's transcranial direct current stimulation, TDCS. Also non-invasive. It uses electrodes on the scalp to pass a very weak, constant electrical current through specific parts of the cortex. We're talking tiny currents, 1 or 2 milliamperes. Not enough to make neurons fire directly, but enough to gently modulate their excitability, make them slightly more or slightly less likely to fire, depending on the current's direction.
A subtle nudge rather than a big push.
Good way to put it. And it's being used experimentally to temporarily boost online cognitive performance during tasks, enhancing working memory, verbal fluency, maybe speeding up learning while the stimulation is on. So unlike meditation's gradual effects or drugs' broad effects, these methods' neurofeedback, PDCS, offer a direct causal link to the brain's electrical activity. They're intentional, targeted interventions, aiming to influence brain function directly, either by training it or subtly shifting its electrical state.
Which means you could potentially learn to fine-tune your brain activity or get a temporary cognitive boost via technology, moving beyond biology and chemistry to direct electrical interface.
That's the direction things are heading, directly interfacing with and optimizing the mind.
Okay, this accelerating ability to hack the mind, it obviously offers incredible potential, but it just as obviously throws up some of the deepest ethical questions we could possibly face. What happens to our sense of self, our identity, our basic autonomy when our minds can be directly changed, enhanced, maybe even controlled? It feels like we're crossing not just a scientific line, but a philosophical one too.
You're absolutely right. This isn't just about can we do it, but should we? These technologies challenge our very definition of self. And there's a huge ongoing debate around autonomy. Does cognitive enhancement, for instance, actually infringe on personal liberty? Think about someone like the philosopher Jürgen Habermas. He voiced serious concerns that technologically programming desirable traits, especially early in life, could sort of lock someone into a specific life project, limit their freedom before they even choose.
Being engineered for a certain path.
That's the worry. But then there's a strong counter-argument that autonomy could actually be enhanced by improving reasoning, flexibility, emotional regulation. If these technologies help us make more thoughtful, deliberate decisions or free us from the shackles of mental illness, maybe the autonomy objections become less convincing. Is a clearer, more stable mind less free or more free?
That's a tough one.
It really is. And beyond individual autonomy, there are massive societal concerns. Social inequality, for one. Imagine if these powerful neurotechnologies are super expensive, only available to the rich. You could create this huge gap, a biological divide between the augmented and the unaugmented, new forms of stratification.
A cognitive class system.
Potentially. And then there's the core existential question: identity, personhood. We hear anecdotes, patient testimonials, describing feeling like they've lost their own identity when an implant is removed or stimulation stops. It suggests our sense of self, our personality, is maybe more tied to our specific brain biology than we like to think. And this pushes the hard problem into new territory, too: artificial intelligence. If a machine can be conscious, and theories like IIT offer a way, controversial maybe, but a way to quantify consciousness in any system, synthetic included, well, should it get rights? Personhood. This isn't just sci-fi anymore. It's a real issue we need to grapple with now.
Before the tech forces the issue. So as you think about this, how might your sense of self, your freedom be impacted? And who gets to decide what an improved mind even looks like? Whose values guide that?
These are the critical questions for our time.
And what's really unsettling is many of these ethical issues aren't just for the future. You could argue our minds are already being hacked every day in subtle, pervasive, powerful ways, often without our explicit consent. It's happening now, isn't it?
It absolutely is. If we connect this back, the hacking of consciousness already has this dark side that's fully present. Digital platforms, especially social media, are masters at exploiting our basic psychological vulnerabilities, whether it's by design or just how the algorithms evolved. Think about how they constantly trigger the brain's salience network, the system that flags what's important. All those notifications, pings, alerts, creating this false sense of urgency for often trivial stuff. It hijacks our attention.
Making us hooked.
Exactly. And this constant, unpredictable stimulation, especially of our dopamine system, the reward-seeking system, it leads to what some call endless loops of seeking without fulfillment. Your reward system is always buzzing, driving this desire for novelty, validation that's never quite satisfied. Keeps you scrolling, clicking, engaging. It's a finely tuned system to capture and hold your attention, shaping your conscious experience minute by minute.
That sounds disturbingly like addiction mechanics.
There are strong parallels. And this manipulation of our cognitive and emotional triggers, it mirrors techniques used in cybersecurity, social engineering, exploiting basic psychology, fear, trust, curiosity, to get people to click the link, give the password, bypassing technical defenses. The human mind is often the weakest link, the easiest point of entry. So understanding how technology can hack our psyche, shape our thoughts, emotions, attention, and satiety is becoming a critical form of self-defense for us as individuals and for society's collective mental autonomy.
So you, the listener, are likely experiencing this right now through your phone, your apps. Recognizing these mechanisms, seeing how your brain is being targeted, that's the first step to protecting your mental space, your well-being.
It's essential digital literacy for the mind, really, asserting conscious control in the digital age. Hashtag tag outro.
So after all that, what does it all mean? Where does this leave us? Our deep dive took us on quite a ride, didn't it? From the weirdness of dreams to the precision of neurotech, ancient practices, modern drugs, it really paints a fascinating synthesized picture.
It really does. And the core takeaway, I think, is quite profound. When you analyze all these diverse altered states, natural ones like dreams and flow, chemically induced ones like psychedelics, technologically guided ones like neurofeedback, you consistently find the shared set of underlying neurobiological principles. All these states, one way or another, seem to modulate key networks, like the default mode network. They tend to weaken that rigid self-referential thinking, increase cognitive flexibility, shift perspective, alter our baseline state.
So different methods, same target.
Fundamentally, yes. The ultimate goal, regardless of the method, seems to be altering the flow, the integration, the interpretation of information in the brain. And by doing that, reshaping how the brain constructs our reality and our sense of who we are within it.
And it's amazing to see the spectrum of these hacks, from the slow, patient work of meditation, building those structural changes over years, to the rapid chemical catalyst of psychedelics, throwing open those neuroplasticity windows, or the direct intentional control offered by BCIs and neurofeedback. They're all aiming, consciously or unconsciously, to tweak the brain's operating system, to reshape our conscious experience.
Exactly. And the future of consciousness research really lies at the intersection of all these approaches. By integrating data, rich data from neuroimaging, nuanced insights from neurochemistry, targeted interventions from neurotechnology, we'll be able to build a much more comprehensive, truly multimodal map of consciousness. This integrated approach won't just let us observe altered states better. It will let us induce them more precisely, analyze them more rigorously, quantify them in ways we couldn't before.
It feels like this journey into inner space, into consciousness itself, might be the last great scientific frontier. And this ability to hack the mind, it offers just incredible opportunities, treating disease, enhancing cognition, improving well-being. But that power, it comes with absolutely immense ethical weight, huge responsibilities.
Immense, yes. As we gain this power, we have to deliberate collectively. Who gets access to these world-changing technologies? How do we ensure safety, protect privacy, prevent misuse? And maybe the biggest question, how do we preserve our sense of identity, our autonomy, our shared humanity, in a world where the very core of the self, the seat of consciousness, can be directly modified? How do you think we should navigate this new era, an era where what it means to be conscious can be actively changed, enhanced, maybe even redefined?
A question that will definitely shape our future. Lots to think about.